So for the first question, you were being asked to give an estimate. I'm going to ask for some volunteers to give us your estimate and how you came to that estimate. So let's hear with Soleil. Starting with Soleil.
My estimate was 5.5.
For the side or for the area?
For the wait, what?
Are you saying 5.5 for the side? Okay.
You want me to explain why?
Yeah.
Because if you like turn circle.
Okay, so if you turn or rotate the circle.
Yes. It should end up around 5.5.
Okay, so you're thinking that this is going to end somewhere in the 5.5 area. So if 5.5 is your estimated side, what then is your estimated area?
Like 30?
Okay, so you're saying like 30? Okay. Do I have an estimate that is different from 5.5 and different from 30? Leslie.
5.5 would be 25.
Okay, so it seems like your side estimate is 5 and your area estimate is 25.
No, it's 30.25.
And Leslie, why did you choose 5 rather than 5.5?
Because the point ends exactly on 5 on both lines.
Okay, you're noticing that this point is lined up on the coordinate that says 5. Okay, I think I saw a hand right here. Anyone wanted to have a different estimate? Dennis.
5.
You said 5 as well? Okay, and does that mean you also got a 25?
No, I got 37.5.
Okay, so you got 5 for the side and an area of 37.5. Okay, I'll leave it open for one more. Is there anyone else that has a different estimate from 5.5 or just 5 that would like to offer their answer? Donovan, is that a hand?
No, I'm just confused.
Okay, so that was question 1. Question 2 is asking for a precise answer. And for a precise answer, it's going to be hard to actually know if this is 5 because, again, the note that we just took earlier told us sometimes you're going to be asked to find the area of a square whose side lengths we do not know. This is one of those examples. What then did you continue to write in your notes as an approach that might help you? If we don't know the side length, what could we do?
Enclose the square.
Enclose the square in what?
Another square.
Enclose it in another square, and what's helpful about that?
You could count the outside.
Yeah.
Okay, so again, the whole point of enclosing it in a square is because while we don't know the side of this line, if I enclose it in a square whose size I do know, and what I mean by that is I can actually count that this side is actually how long?
1, 2, 3, 4, 5, 6, 7.
This is 5, yes, but if I enclose it right here with 2 more?
7.
7.
So then, is it actually 5 or 7?
I'm enclosing it in this larger one, so it's going to be 7.
Okay, then how do we get 5?
So a 7 by 7
49.
squared
9.
has an area of 49.
I knew it.
And
Just
then,
like in the previous examples though, there are 4 triangles that are surrounding the one that I care about. So I'm going to ask myself, the area of the triangles, remember, base height divided by 2 is going to be, here's the 5.
times 7.
What's the height right here?
2.
Don't
2
say.
divided by 2. 6. So 5 times 2
10.
10.
divided by 2.
5.
5. I said it first.
I have 5 for one triangle.
So
But I
then
actually
you apply
have-
to all the triangles.
I have 4 triangles.
Right, so it's 20. And then 49 minus 20 equals 29.
So that means the area of this entire
Wait,
square
29?
is actually 29. So that means we were close with 30, we were close to 25, 37.5, we were
Far.
way too off. But in between these two, I think it's reasonable to say that we have a fair range. Now, I told you before we started this activity, we were going to see a square that has an integer for the area. What's funky about finding out the actual side length?
It's sideways.
It's sideways, but okay, let me ask you this. If I told you that the square here had an area of 25, and then I asked for the side, some of you can easily tell me that the area with 25 would have a side of 5.
Yeah.
Why is it not so easy to answer that same question with an area of 29?
Well, because
Because
you gotta
you don't know
split
the-
it up.
You don't know.
Yeah.
And it's gonna
You
be
don't
a
know
decimal.
Yeah.
Okay, so I'm hearing we don't know the multiples of 29.
Right.
I'm hearing it's going to be a decimal.
An irrational number.
It's going to be an irrational number. Now, given this is the first lesson of this unit, so I don't expect everyone to know what an irrational number is. But 25, we know, is a nice number that can be broken down into 5 times 5.
Wow.
29 is one of those numbers, and there exist many who don't have two perfect numbers that are whole numbers that'll give us, in this case, a 29. So when you have that, and you are being asked for a precise measure of the side rather than an estimate, your answer is going to be square root 29. So this little check with a horizontal line at the top, we call that square root.
Square root.
So if the entire square in the blue has an area of 29, the side is just the square root
Or
of
29.
29.
What does square root actually?
Square root.
Lowest point or like?
So square root is kind of just like the side of a square, right? Because if the entire square has side squared, the square root of that would just give you the side. Yeah, so for our essential question, which is what is the square root, some of you might want to start thinking about, well, it's kind of just like the side of a square. We're going to be using square roots to help us think through some other shapes shortly.
Literally at 15 minutes.
That's fine. I erased this last part, sorry, because I want you to actually have something easier to look at to write. And this is something that you do want to write in your Cornell notes. It is that summary of a square root. That's a